Thank you so much. You will wonder why we have so many Italians today. I don't know, but at least I have a famous surname if you are a football fan. But let's start. I'm a cloud solution architect and AWS team lead for North Cloud. I'm also AWS community builder. And today I would like to talk how to approach data challenges or data problems without really a big knowledge, without being a data guy. But let's start. North Cloud is a consultancy company specialized in cloud. We do AWS, but also other cloud provider. We are part of IBM Group, and we follow all the cloud journey. So basically from the strategy, the landing zone, migration and modernization of the apps, security posture, and we manage also the service when we deliver our solution. But let's move to our topic. And our topic is a customer journey. It's a real use case. It's something that we experience in our life. This customer is a really big customer, has around even more than 6,000 accounts in AWS, and is using AWS for a lot of years, and basically has a landing zone where all the logs, audit logs that are from CloudTrail. CloudTrail, if you don't know, tracks the user behavior inside the AWS account, and config that tracks all the difference in the single services. For example, the change settings in S3 or EC2 machines are stored in the user account, but then are replicated to a single account that's called, we can call the log account. And all these logs are stored in S3. What's the problem? That everyone AWS is saying, yeah, S3 is cheap. Yeah, it's cheap when you don't have so much data. So, but when you have a big numbers, here we're talking about around 70 terabytes of data, of logs, you will pay 1,000 euros only for logs that maybe you will access sometimes, maybe a few times per month, maybe logs that are just there for auditing or for laws and so on. So the customer come to us and say, we read that there is this S3 Glacier that's cheaper than standard S3. That's true, technically it's true. You will pay less for what your storage. Of course, you will have something, you have more time to retrieve this data. You are not able to retrieve this data immediately. You have to usually to wait. It depends on the storage class that you configure, but it's definitely cheaper. So our engineer go back and configure this lifecycle policy. A lifecycle policy, basically, it's a configuration S3 where you can say, if I have, for example, the files or the logs that are older than, for example, 3 months, I want to migrate this information from standard S3 to S3 Glacier. And then perfectly fine, okay, we can configure from console, from Terraform, CDK, whatever you want. Then we ship this code, and usually the lifecycle policy are applied at midnight. And then we start to see an exponential growth of the costs. There were 100, 200, 3,000. Then at certain points, AWS stop it and call us, what are you doing? You're spending a lot of money. So what's on your mind? And we reply to them, but what? You say to us that's Glacier. It's technically cheaper than we did what you asked to us. But in reality, it's true when you don't have a lot of files, because you will pay a really small fee, 0.036, every 1,000 files that you transfer to a different storage class. But then you have to imagine that CloudTrail and config are configured to create a single file every 5 minutes. If there is activity in a single account, then you imagine having years of logs for 6,000 accounts. You can imagine how many files you can have. And then fortunately, they stop it after 1 hour and a half. So we didn't spend so much. But we had to find another solution. because it was not a practical way to spend a lot of money just to move this data without any advantage. And I would say that this is the classic of the cloud paradox. Everyone is start to use, everyone is following the hype. The cloud is the best thing in the world. It's cheap, it's easy to work, and then they will experience maybe cost problems, or something is lower than they thought, or it's not working as they expected. But I think it's always a process of learning and optimizing the solution to the cloud. That's completely different world to on-premise and other type of software. So I will show you first the first solution that we had in mind, and then an iteration of this solution and how we improve this solution. But let's start with some requirements. We definitely want to save money from the data that is stored on S3. This is the objective and the goal. Then the customer has already another system, log system, that is called Splunk. This Splunk is a third-party tool that is ingesting these logs. But don't ask me why, but the team that is managing this tool probably didn't configure really well the Splunk. It's pretty slow, sometimes it's offline, so it's not the best implementation in the world. So they want to have also a plan B where you can not only saving money, but they can also access these logs in a faster way than maybe go through S3 and find the right file and the right moment, and so on. Then another strong requirement is that from the customer point of view, they don't have data experts. And also in the team that is working the project from our side, there were not so many data experts. So what we want to do is to find a solution that should be easy to manage and to also extend it from the customer in future, so that they don't need really data engineers or data scientists or whatever. The first choice that we had to make is to which type of streaming, of processing that we have to apply. For example, streaming versus batch. Streaming data pipelines are now really trendy. Everyone is using data stream pipelines, but we really need these things for our use case. I mean, we don't really need to aggregate this information, or we really don't want to transform this data immediately or after 5 minutes. We want to maybe aggregate this information every week or every month, and paying more and having more complexity in our code just to implement something that's now a trend, it's maybe not the right solution. So we decided, okay, let's go in the old classic way of a batch processing. In this case, for our use case, we decide to go for 1 month of aggregation process that I will explain you later. Then, but what's the CloudTrail data structure? I mean, it's a bit complex. Probably you can see because it's really small. And basically, it's a JSON with a lot of data, but also we have an array of data with an array of objects. It's pretty complex because you can see when the event happened, what happened, or who was the user, and a lot of details of configuration and so on. So it's a really big, complex data. And the first thing that we want to try to optimize is the data format. This data is stored, I mean, it's dumped to S3 from CloudTrail and config as many AWS services in JSON. JSON is a really nice data format, especially for developer and so on, because you can read the content. It's pretty good to write with the code and so on, but it's not really the most manageable and the faster data format in the world if you want to also read this information with a data tool. And another common file used is CSV, but CSV in this case was not usable because, I mean, it's not able to handle complex data types like arrays and so on. It's not really a good choice for data processes. So what we had to do, we thought that Parquet was a really good compromise for us because it is really fast in terms of reading these files if you want to query this information later, and also a columnar file, so we can also saving some storage, and is able to handle a complex data structure. The only one counts that we can open a Parquet file and reading the content, but we can use other tools like Athena to understand the content of these files. And another choice that we have to make, it's, of course, we want to save space on S3, and we want to use a codec that is compressing the information, but you have also to think about that we are not only storing this information and forget about this data. So sometimes we want also to analyze. So we want to have a codec that is saving storage, but it's also at least not so slow to uncompress this information. And the Snappy was also a really good choice. But if you really want to have a strong compression, for example, you can use gzip and other tools. And let's start to analyze the first solution design. So we have a cron job, or Ivan Bridge rule, that is calling a Lambda, for example, every 1 month. This Lambda, what is doing this Lambda? We don't want to read the file directly from the Lambda using for example, we are using Python, so using body tree codes to read the file and so on, because it's not really fast, because the APIs from AWS sometimes are not the faster in the world, I would say, especially if you have to scale the process. So what we want to do is to read this information through Athena. Athena, if you never use it, it's a virtual database that is basically reading the information in S3 using standard SQL query. It is pretty fast, it's well configured. And then what? We want to try to reshape, aggregate this information using a glue job. Glue job, it's an implementation of Spark from AWS. In our case, we decided to go with PySpark because the team was really more aware of Python than Java and other languages. And then after we reaggregate this information, we want to dump to S3 the end result. But because why? What's the main objective of this solution is we have too many files. So we have in some way to aggregate this file in bigger files, and also we want to compress these files. Also we want to change the data format in order also to read this information later. But let's go in details. So the first task that you have to do is to understand the content of these files that we have on S3, of this data. The standard way when we work with Glue is to use the Glue crawler. Glue crawler is basically a daemon that is running. You can configure to run every day, or maybe you can configure to run when there are new files. But when you have already a lot of files, the Glue crawler will be really takes a lot of time, like days. And in this case, it's also not a good solution because we have only 2 data schemas. We have CloudTrail and config, and they are not changing. The content is changing, but the data structure is pretty the same. So we don't need this solution, and it was also really too slow. But in other cases, it's a really good solution. So what we do? Basically, in our Lambda, we do some reading on this tree. For example, how many accounts we have, what's the date, starting point, end point, and we extract this information from S3, only metadata, and then we create a table to read this information using Athena. But then, if you use just plain Athena, just to configure, read this information from S3, we are then another time in the big problem that we have to scan all the files. If, for example, if we want to collect one single month from one specific account, if you just don't do any partition, it will take hours, and we will spend a lot of money. So a standard way to optimize the query on Athena is to use partitions. Partitions, it's a way that instructs Athena to where to read when I'm asking, I want to all the files from this account from July, for example. The big problem with standard partitions that the process to create this partition, it's not so fast. So for example, if you want to create a new partition, has to in some way load some information and so on. And also if you want to extend this partition, takes time. So every time that we run the process, we have to change the partition, it will take too much time. But there are another solution that's called partition projection. So basically you help Athena to define partitions that are still not there, but they will be in the future. And this is really fast. It's not fast as the standard partition, but it's fast enough for our use case. And you can create, destroy, and extend partition because they are virtual. So they are just metadata and so on. So it's pretty good. And then we decide to partition for, as I told you, for account and for date. But then I told you that we want to extract this information. We want to collect this information to the glue job that has to do the dirty job to transform this data, then export in another S3 bucket where after months we'll move to Glacier, okay? Here, how we can read the information from Athena through Glue. We have three possibilities. One is to use the Boto3 SDK, so interacting with the API of Athena, sending, for example, the query that you want to perform. Athena will dump the information on S3, and then you will read this information through Glue. Usually, Athena exports the files, I mean, the query in CSV, but you can use unload to export in different format. Then there is another solution. You can use a standard JDBC connector. JDBC connector is a standard way to connect to database, for example, with Postgres or other databases. So basically, you don't need to dump the information, then read it, but you can pass the information directly through Glue. But there is a problem. The CloudTrail data is too complex to handle from JDBC. They never fix it. If they will fix, please write me, because this should be the ideal solution, but it's not possible for this limitation of this kind of type of data. Then there is another solution, is to use Panda. I don't know if someone ever used Panda here. It's pretty good, but it's pretty advanced. You have to also know Panda, how it works. You really need data knowledge. And for this reason, we decided, no, it's not our job. We are not data engineers. So we decided to go to the first solution. And then, as I told you, we will have two different buckets. We will have the original bucket with the raw logs from CloudTrail and config for two main reasons. One, if the automation fails for some month, we still have the original data, so we are not losing information. And then there are probably other also software that are interacting with the raw logs, and they still need access. And then we will have the second bucket. It's the new bucket that will have all the new information, reshaped it, and so on, and will be immediately dumped in an infrequent access storage class that's cheaper than the standard one. And then after some months, in our case, 1 year, we'll move to Glacier. And then in this case, moving to Glacier will be really cheap because there were few files. But then this process was more expensive than what we were trying to save for many reasons. This is not a slide against Spark, but this is a slide against the knowledge that you really need to have a really good performance writing Spark software. Because the glue jobs were taking a lot of time, especially if you are aggregating not for 1 week, but for months. And then the glue job, it's really, really expensive. Then it depends how you configure it, but it's really, really expensive. And of course, as I told you, you need to be kind of expert of data. So what we did, we thought, okay, or we invest more time in learning how to improve this solution, But at this point, okay, we spent a lot of time, maybe we improved, we found the right solution, but how the customer can do that? They should also relearn and so on, so it was not really the best solution. So we tried to pivot in another direction. And here serverless will help us. So now I want to show you the final solution. It's kind of similar. We still have more or less the same architecture, but instead of having glue jobs, we will have a step function, okay? And we will also leverage the help of Athena for having a smooth process. So what we do, basically, we invoke the query to Athena directly from the step function, and we will use especially the direct integration of the step function to Athena without using any Lambda, so we will not have some delays in the middle. And what we do, we invoke a query with an unload, and we export this information directly in Parquet, already compressed with Snappy. How? In step function, you can do parallelism in two ways. You can use parallel tasks. Parallel tasks are basically tasks that are completely different, can have multiple versions of the code, different code, and so on. And you have also the map task. The map task basically takes an input. For example, in our use case, we have the list of the accounts and the amount that we want to aggregate. So the single task will take an input, the account ID and the month, and then we'll execute the same query for every task. And what will do Athena? We'll execute in parallel the query, and we'll export directly the information to S3. Seems easy, but you need to take a bit of time to tune the step function, because you have to imagine that you're running really a lot of queries. And then what? You are throttling S3 APIs, you are throttling Athena APIs, you are throttling step function APIs. So you have really to find the perfect tune for use case. Some of these limits are really soft limits, so you can change in your account. Some of them are not. So if you don't have special relation with AWS, you have to find another solution, or at least have a smarter solution. And then the input-output of the different tasks in the step function, they have also a limited storage. So you have also tried to cut and prune and just pass only the information that you need. Otherwise, you have to storage this output on S3, but you are including another delay. And then you really have to be really good in handling the failures, because failures can happen for APIs errors, throttling, or bugs, whatever. And you have to imagine that a step function is running a lot of tasks, and you don't want to fail for one single task or few tasks. So you have tried to implement a retry policies that you can implement the step function, and if you have to evaluate if you want to fail, you want to fail the whole process, or you want to fail the single query, for example, and maybe sending an SNS notification to the developer, and then we'll analyze why that query was failing. Another thing, the step function, at least the standard version of step function, has a limitation on the number of steps. So sometimes you can also reach that point. A fast solution is to split the input and run multiple step functions that will run in parallel. And it's perfectly fine, and you will not pay more. It's perfectly the same solution. Then I want to show you how to use unload. This is really simple. So basically, you select the query that you want to do. And then you export all the information on a S3. And then you decide the format and the compression. And you can also decide if you want one single file or you want multiple files. This is really fast. It's only implemented from AWS. You don't have to do anything. But you have to take in consideration the cost of all the different services. For example, Athena, it will cost you only for the time that you are running a query, okay, more or less. So you have really to optimize the query in terms of data partition, of filters. You have to select only the amount of data that you need in order to optimize the query. Then, if you have data that are encrypted using KMS, this costs a lot of money, because every time that you are interacting with S3, reading or writing, you have to also, S3 has to contact KMS. Every call to KMS is costly. So if it's hard requirement, you have to take in consideration this cost. Otherwise, you can use the standard S3 encryption that's more or less free. Then S3, it's really good to start to understand the use case and decide immediately the right storage class. But of course, you can change it and optimize it, but you know that there will be some cost. And step function, the major point is really you have to optimize how you handle errors. Because otherwise, if you had to rerun the whole step function, it will cost you more and more. Then, just to remind you that I think what I want to bring to you for this, with this talk, it's really, you have to study the specific use services, really reading documentation, especially on the cost, because there are some costs that are really hidden or that you don't know, and you have to take in consideration, especially when you are working with big environment, because everything is easy when you have maybe one account or not so much traffic and so on. So you can do, at least you can try to experiment more and not losing a lot of money. And I think when you're building a solution, you have really to stick on simplicity and try to evolve this solution later and make different steps. And if you're making mistake because it's too slow, it's too costly, or too complex, you can always learn from this process and then change your design. And then I think we can do intensive computation, maybe not every use case with serverless, but of course we have to really play with the different services and optimize. It takes time, but we can do that already right now. I'm done.
Round of applause. Thank you very much. That was a really, really powerful solution. I'm yet to come across any case study where we've got 6,000 Amazon accounts. So that's pretty impressive. Any questions for him? No, one over here.
So you said you got 6,000 accounts, and I'm assuming all of these S3 buckets, like all of the data that are being processed, is like distributed through multiple accounts. How are you applying, like when you decided, oh, I'm going to use glue, and oh, actually using step function is better? How are you applying all of these changes like to all of these accounts?
We don't do that because in CloudTrail in config, you can already configure to say, we storage the original logs in the user account, but then you replicate also this information to a centralized account. So the data is already replicated from AWS under the hood. We are just reading data from one single S3 in the centralized account. 70 terabytes of data, but still we are reading from one single account.
Anyone else? Any more questions? There's one at the back over there.
I had one question about partitions, and it was, did you like pre-allocate the partitions for like future days? So you didn't have to use glue crawlers, because that's a problem we've got. We have to know to run the crawler when the data's going in.
Yeah. I mean, as I told you, we have two types of partition, accounts and date, right? Date, you can pre-generate. You will know that you will have this information from this year to, I don't know, 10 years, 20 years in the future. So you kind of pre-generate. The only thing that is changing is accounts, because account can be closed, can be new accounts. So you have to read this information, recreate the partition for this new account or cancel these virtual partitions. This is what we are doing, and this is what the Lambda is doing, reading information through S3, but you can also use, if you have APIs that has this information or databases.
Brilliant, thank you. Any more questions? One here, one. Yeah, I'll come to you.
So another question, I mean, with Athena, we found that it could be quite slow and the number of concurrent queries you could run is limited. And when you have like so many data coming through and you're trying to process all of them, I know like partitions can speed it up a little bit, but you could quickly hit the limit. How do you manage that, or how do you deal with that?
Yeah, Athena has limits to the number of queries that you can run per second. This can be upgraded to your account limit, so you can reach a certain threshold. And what else? For example, the step function is running a subset of tasks for every run. For example, we'll run 20 queries, okay? You can configure that. And then until all the tasks are done, you are not moving to the next batch. So you can play with these times. For example, you can understand that if you're running 20 queries per second and then you have to wait all of them, more or less, you're waiting, I don't know, 2-3 seconds. So, and then if it's failing because Athena is replying to you, we don't have enough capacity to run the query, you can retry. And then with these random retries, you can manage the way. Of course, it depends the scale. Athena, it's maybe not for really big scales. Maybe you need other systems. But for batching processing or reading the right amount of data, I would say that's trickable to work pretty good.
Anybody else? One over here, Rosh.
Who was that again? Oh, anyway.
Hello. What was the kind of ratio of cost savings from like S3 to Glacier against all the bits you're running to try and get it into Glacier in the first place?
You are asking me how much we save instead of moving data to Glacier.
So yeah, if like the cost of S3 against the cost of it in Glacier, how much did you save? You don't have to give me the exact number, but like ratio, was it? When did you break even, basically?
Yeah. I can't disclose exactly the right number and so on, but we evaluated with AWS that mass migration will costly around 100,000 euros to move directly to Glacier. And for this system, we are spending no more than 100 euro per month. And the total cost that we are saving from a standard S3, it's more or less around 60% of the original cost. And I would say that this is a plan B solution, so maybe you can still optimize, but this is what the customer wanted.
Brilliant, thank you. Anybody else? Any more questions? We've had a nice, engaging audience today, haven't we? Brilliant. One big round of applause for Fabrizio.